Today we get to start 712 and work on graphing some of our sine functions. So we'll spend today and tomorrow on this section for you guys. So today we're just going to, our learning target is to be able to graph a sine function. So we've kind of talked about sine here and there in a little bit, especially when it comes to like triangles, and then we just started it with the unit circle, and then now we want to be able to graph it. So we're going to look at some right triangles that we can create so we can figure out those sine values, and then we'll be able to graph it. Right. So ultimately, this is what we want to do. If we look at our unit circle, we started talking about those on the circle. The circle is made up of a whole bunch of points, right, that are really close together. And points are made up of those XY coordinates. And we learned that when it comes to that Y coordinate, that Y coordinate is our sine value, right? So we want to be able to look at our graph, take our circle graph, and look at all of our Y values and see if we can find all of our Y values, and then take those Y values and make it into a graph. Doesn't that sound exciting for a Monday morning?
It does. This is exactly what I wanted to do this morning, too.
Absolutely. Right? All right. So we're going to see how close we can get it to look like that with my beautiful drawing, right? So I kind of sat there and I just drew, well, I didn't draw. I copied and pasted a photo of a nice little circle that had part of like the points that we need to look at. And I threw it down by the bottom because I'm hoping I don't make you guys dizzy, because we're going to like find points and then graph it. So I figured to try and make it big enough. To make it big enough. I know, and then I didn't change, and I don't think I can change my, oh, if I can just move it. Well, I think we're good zoomed now. But then I can hopefully not make it too busy, right? All right. So if we look at our fancy-dancy little circle here, we can kind of fill in some values, right? We know that if we go all the way around the circle, we go how many degrees?
360.
360, right? Or if we didn't go at all, it would be 0. So our 0 and our 360 give us that same measurement, right? And then up here, we would make a cute little 90-degree angle, right? So up here on the top would be our 90 degrees. All the way to the left would be how many degrees? 180, yep. And going down would be 270, right? And we worked on those the other day. Ooh. So now we want to work on some of the other little measurements, some of the other little degrees. This point is halfway between 0 and 90. Okay, so how many degrees do you think that guy's going to be? 45. Look at you go. I'm kind of like not exactly sure where I want to write all of these, but we're just going to write it over here. 45 degrees. Right? And then when it comes to our unit circle and having some of these fancy little angles that are in there, and remember last lesson we kind of talked about how this makes a cute little perfectly right triangle for us. So we actually go 15 degrees less than and 15 degrees more than the middle. So this guy becomes 30 degrees, and this guy becomes 60 degrees. And then that will make us to where we can actually draw out a 30, 60, 90, or a 45, 45, 90 triangle. All right? You guys remember all of those little formulas? Kind of. We can write them up here. So on a 30, 60, 90, not completely drawn to scale, but to try and kind of get it to look like it. All right, we got 90 degrees. This bottom angle down here would be our 30 or our 60. This one down here.
60.
Yeah, that one's going to be our 60. You can kind of look at it and it kind of looks like a bigger angle, but we know the hypotenuse is always going to be the longest one, right? Because that 90 degrees is the biggest. So between our two sides, that longest side corresponds to that biggest angle, right? Because if you think of I always think of like an alligator in a sense, right? When that alligator opens his mouth, that angle is getting bigger, right? And then that distance of his lips is getting bigger, right? As he closes his mouth and he gets a smaller mouth, the distance between his lips gets smaller and smaller, right? So there's always that direct correlation between that angle and that opposite side. So if this is our biggest angle, this has got to be our biggest side, right? So, if we're looking at a 30, 60, 90, this is going to be our 60, and the one up on top is going to be our 30. I don't think I like pink on the black. It doesn't seem like it shows up very well. And then the little formula, we always kind of call it our short side. You can call it whatever variable you want. What variable you want to call it? A? You like A? You can have A. And then the hypotenuse is like 2A. And that long side was A times the square root of 3. Sometimes I like using letters other than X's and Y's only because when we're looking at that coordinate plane and that circle, we're looking at X and Y's as our points. So then sometimes when we plug in that X, we think that that's the X value for our coordinate, right? And that's just the variable. So sometimes I like to use different letters. And then when it came to the 45, 45, 90, when it came to that perfectly drawn triangle, if this guy's 45 degrees, what do we know about the other angle? It's 45. And what do we know about the two sides, this side and this side? What do we know about these two guys in a 45, 45, 90? They're the same, right? That same thing, right? There's that correlation between angles and sides. So this guy could be A, this guy could be A, and then our hypotenuse was A times the square root of 2, right? Remember finding all those?
Yeah.
Yeah. We're going to hopefully not go through and use all of them, but you might need them for your homework a little bit. So it's good to have those tucked away someplace in your notes in your back little pocket. If you actually look in our CPM book, if you go through this whole lesson, there's always those little math notes that are in there. And actually at the very bottom of the math notes, it actually lists these out as well for you guys. So that way you can remember how those little formulas all worked. All right. So I'll leave it up there. So we're going to go through and see if we can kind of figure out some of these values. So one way you could do these is like if you think of that 30-degree angle, right? We could drop down that perpendicular. Oh, that pink blue don't work very well on that. You think this was my first little rodeo, wouldn't you? Right? And when it came to the unit circle, what did we know about the unit circle? The unit circle always has a radius of 1. So how do we get to the radius? By definition, what's the radius?
The center point to the outer edge.
Yep, so from the center point to the outer edge, right? So that would be a distance of 1. Whoop. Right, in our little triangle. Would from here to here be a distance of 1? No, because we didn't go all the way, right? So, and we know that we're looking for that 30 degrees, so we know we're looking at that 30, 60, 90 degree triangle, right? So we're going to use this little formula. And what value did they give us? Did they give us the hypotenuse, the short leg, or the long leg? That 1.
The hypotenuse.
That's the hypotenuse, right? So since that's the hypotenuse, it fits into this formula, right? Into this side. So we know that 2a has to equal what? It has to equal 1, right? So if we put this over here on the side, whoops, 2a equals 1. So what's our a going to equal?
2.
How about half?
Oh.
Right?
Yeah.
Divide both sides by 2? Yep.
Yeah.
Yep. And then that A is our short side, right? So on our triangle, where's our short side? That's this guy right here. So we know that that guy is a half. I'm gonna, whoop. And when we're talking about signs, and we're talking about the x's or the y's, we're talking about the y values, right? So we want to know how high it goes up. And we just found the height, right? We just found out that it goes up 1/2. So when it comes to the sine of 30 degrees, we know that that's going to equal 1/2. Right. And then last week, we actually put it into our calculator, right? You guys all got your calculators? And if you put in, as long as you're in degree mode and you put in sine of 30, guess what you get when you put in sine of 30?
30.
You get half, right?
It's close.
Yep, yep. So do this one for me. Yep. So now you have an option. You can either put in sine of 45 into your calculator, or we can look at this special right triangle and put in some values to see what our value is. I'll wait until somebody spits out an answer. No, that's the sine of 30. We're doing the sine of 45. And it can't be a half because this is telling me that this is going up a half. And if I'm going up to here, that looks like more than a half to me.
2/3. What do we do, like fractions, everything?
Well, it's got to be half.
Is it 0.71?
Yeah, 0.71. Yep.
Did you have, actually, I could.
No, I can't do that in my head.
Yeah, I can't do that in my head either, right? So the sine of 45 was 0.71. Okay. What about 60 degrees?
Geez, that's another height.
It's got to be more than 0.71.
Yep, good job, yep.
0.83.
0.86.
Dang, I was close.
Or I think it actually, isn't it going to be 8?
It's like 0.9 then.
Yeah, so we'll go 8.7, right? Just, yep. Cool. What about 90 degrees? What's the sine of 90 degrees equal?
1.
1. Good job. Awesome. Yep. How high are we? 1, because we're looking at the unit circle, right?
That's your radius.
Yeah, it's the yes, it's the radius. Yep. Good job. Right?
Well,
So then we got talking about this a little bit. Well, I guess we can fill in now. So I'll show you. Usually when it comes to unit circles, and then when it comes to them filling in the angles, you know how the one that we have drawn is at 30 degrees? Then they'll sit there and they'll write 45 in that little spot. And it's not that that little, where that little sliver is 45. It's from the x-axis to there is 45. Right. And then they'll write in a little 60. So that's not saying that this little sliver is 60 degrees, but this is 60 degrees, right? Because our initial side's going to stay the same. And then we go up to 90 degrees. So let's see if we can fill in some of our other little angles over here. So these are referred to a lot of times as your reference angles. So you can kind of always refer back to those. So we know that in the middle, that's 45 degrees, right? So if I started at 90 and I wanted to go to this middle angle, it would be 90 plus what to get to here? 45. And what's 90 plus 45?
135.
135, yep. So we can write in 135, right? And then there's this 15-degree variation. So if I subtracted 15 degrees from that, I would get 120. So that would be like 120. If I added 15, I would get 150.
Wait, what? Oh, I think that's cool.
No, you're right. Yep, right. And then we have our 180 degrees, right? So to figure out that middle degrees, you do 180 plus 45, which is going to give us
200
the 225,
Yes.
maybe. Yep. So to figure out the little smaller one, what are we going to do? Subtract 15, so we're going to get 210. If we add 15 onto 225, we get 240. Good job, good job. Right. We know this guy's 270. Right. 270 plus 45 is going to give us
315.
315, yeah. If we subtract 300, we get, or sorry, if we subtract 15, we get, yeah. If we add 15, we get 330. And then we're back to 360, right? If we go all the way around. So now we could play around with our calculators to figure out these sine values. Or maybe we can use a little, remember when we learned all of our quadrants and how our quadrants affect our sines on our x's and y's? So we know that in quadrant 1, all of our y values are positive. And luckily we got all these positive values. What's our y value going to be in the second quadrant? It's all going to be positive. So we can just use reflection, right? If I think of this angle right here, or this point, if I take him and I reflect it over the y-axis, I end up right here, right? So what's my y value going to be at 120 degrees?
0.87.
Yep, 0.87, right? My 45 degrees, if I reflect that over the y-axis, I get that 135, and what do I get?
0.79.
Yep, 0.71. What's my 150 degrees going to give me? 1/2, or we'll just do it as 0.5 since we got all the other fractions, right? What's my 180 going to give me for my y value? What's my y value right here for 180? 0. Okay. So now I can keep going around and keep reflecting these, but now that I'm in the third quadrant, what are my y values all going to be? They're all going to be negative. So this guy is going to reflect over the x-axis to here. And so that's going to be now, yep, negative 0.5. My 0.71 is going to reflect to here, right? Negative 0.71. And this guy's going to be negative 0.87. And then now if I go into the fourth quadrant, my y values have to be negative, right? This 224 is going to reflect over to 300 degrees and give me
Negative 240.
negative 0.87, right? 315 is going to give me a sine value of 0.71, and 330 is going to give me negative 0.5. Then when I get back up to 360, what's my y value going to be? 0, right? So now we could take all of those values and we could actually plot them onto a graph. But let's think about our y values. What's happening? So our y values are starting at, where are they? What's our y value right here? 0. And what happens to our y value until we get up to 90 degrees? It's going up, right, until it gets to 1. And then what happens from 90 degrees to 180 degrees? It goes down. What happens from 0 degrees to 270 degrees? It keeps going down, right? And then what happens from 270 up to 0 or to 360? It starts coming up. So we get this up and down motion. So we get starts with a W, see them in the ocean, it's a wave, yeah. So this gives us a sine wave, right? So we're not going to get extremely fancy on our little plots, but I'm gonna slide it a little bit over to the left more. Whoops, hopefully there we go. All right. Fill in some of these values. So we're gonna start at 0 degrees, and we're gonna keep going until we get to how many degrees? 360. Yep, nope, yep. All the way around the circle is 360 degrees. Okay. No, I just did it. I did it, and I bet you it's going to kick me out. So we said halfway, right, it was 180 degrees. Whoops, I'm going to write these on a little bit of an angle so I got room. Half of 180 is our 90 degrees. In between 180 and 360 is our 270, right? And then we knew that like that 45 is halfway. So we can actually mark this guy as 45. We can go with what? 45, 135, throw that guy in there. This would be what, 225? And this one would have been our 300, right? And we still got a couple angles on the either side. So like technically you would have like that 30 degrees and that 60 degrees, right? But we're just not going to add all of those. That's going to get really fancy, nasty, right? All right. Now we got to talk about, they call it our amplitude, or how high our y-axis is going to go. What's the maximum y value we could get? So, what was it? Yeah, it was 1. What's the lowest y value we could get? What would that value right there be?
Would it be -1 or?
-1. Yeah, because you went down. Yep. So then when they talk about domain and range, range is your y values. So your range goes from -1 to 1. Okay? So on our graph, and we're going to put it up a little ways, our highest value is 1. And our lowest value is -1, right? And I always start by plotting kind of the, like the 0, 90, 180, 360, right? So we're only talking about our y values. So at 0 degrees, what was our y value? 0, right? So we got the point 0, 0. So that guy's right there at the origin, right? At 90 degrees, my y value was at 1. So at 90, I'm at 1, right? At 180, my y value is 0. So we can plot that guy. You guys picking up on what I'm laying down, what I'm doing here?
Kind of.
Right? At 270, my y value was at -1. So at 270, I was at -1. And at 360, I'm back to 0, right? So let's just do a couple of these points, all right? We'll go right in the middle. So at 45 degrees, what did we get?
0.7.
Yep. So at our 45 degrees, we're above half, right? So right about there-ish. And then at 135, we were at 0.75, right? Or 0.71, sorry. At 225, we were at negative 0.71. And at 300, we were at negative 0.71. So do we kind of see what we got going on here? Yeah, it's a wave, right? Because then even at 30, we were at a half, so we could put that at, and if we wanted to, right? So we're going to get this little guy. Sometimes in life, you make your dots a little bigger if you have to. And this guy's going to keep going, so we're going to make sure we throw some arrows on the end. I'm having some really sloppy arrow day. Okay. So these technically go on and on forever. So depending on how many times you go around the circle, that cycle will keep continuing. So this is like one cycle or a period of it, right? Of going all the way through. This is one whole loop around the circle. Do you want to go around again? Oh, now we'll go peachy, right?
Is that why like they made the infinity sign the way it is?
Oh, I wonder. Yeah, because guess what cosine's gonna do? We'll have to, yeah. Next week, I think we do the cosine, and then we'll have to sit there and put the sine and the cosine graphs on top of each other and see if we get an infinity symbol, right? Right. So good things to remember when it comes to sine. We always want to make sure that our y values is what equals sine. Right? Because next we're going to get into that cosine, and cosine is going to be what value? X, right? No matter, when you're graphing, I'm just going to call it the parent function of sine. Sine functions go through the origin. Right. Granted, we can get some variations of this, but that parent function of the sine will go through the origin. Because the cosine will not, right? Because those are looking then at the x values. So